Yeah, Suchin brought up a very good point. Computer technology or technology in general is going to resemble more and more to arts like music, right? Or sports. Just like if you think of any successful sports person, take any successful sports person. Majority of the ones who are at that national level would have taken up sport when they were very young, 9, 10 years of age. And unfortunately, in India, we ask students to pick a stream when they are 10th graders, which is what, 15, 16 years of age. It's not enough time for them to even to understand the world.
Welcome back to HigherEd Horizon, a podcast where we explore emerging careers, education pathways, and skills that matter for Indian students today. Today, we are talking about robotics, a field that often sounds futuristic but is already shaping manufacturing, healthcare, agriculture, logistics, and automation across India. So, for many students, robotics feels exciting but also confusing. So, in today's episode, we'll break this down clearly from what robotics really means and how Indian students can build practical pathways into this field. To start us off, when students hear the word robotics, many imagine humanoid robots or science fiction. From your perspective, what does robotics actually mean today, especially in the Indian industry and education context?
So, if we look at robotics, people mostly think about industrial robots because industrial robots are the ones which are increasing productivity by many orders of magnitude today. So, you go to any factory, you will see many tasks in the factory which would have been done in the past by humans are being done by these six axis robots, which don't look like a human. They look like only a big humongous arms, right? Even when the car is being put together, and the whole chassis of the car, all the panels being put together and welded, or even the car seats being moved inside the car, much of it is robotics driven right now, even the glasses to be put on the car. So these type of robotics has been around for a while, and it has progressed tremendously over the years. There are many companies from around the world, primarily from Japan, Germany, who make amazing robots like these. So those are industrial robots. Uh, these robots are usually explicitly trained on repeated action. So if there is a robot that's supposed to pick a part from a moving conveyor on one side and put it on another side on another conveyor where it might get um, filed or painted or what have you, it is always that repeated motion it does. It always picks it and drops it. Or if it's a panel to be put together in a car, it is always the same kind of action it does. So, but it has to do it reliably, always, exactly, precisely, and it has to do it at a very high speed. That's why the actions done by these robots are many times even of higher quality. Tolerances are very low, they're perfectly done, and they're done very fast than what a human can do. But these actions are programmed specifically one by one. There is no AI involved here, right? This kind of robotics has been around for quite a long time. In fact, when I started my career in industrial automation almost 20 years ago, I actually went through a course at a place in Spartanburg in North Carolina. I think South Carolina, Spartanburg in South Carolina. It is a company called, um, I think I forgot the name of the company now. It was right next to the BMW factory because the BMW was a big robotics user at the time. The company name was Stoblei Robotics of Germany. And they were doing all this robotics programming and training at that time, 20 years back. So, what skills would be needed for someone to get into that kind of robotics? That robotics traditionally has fallen into a um, path of engineering called industrial controls. I was also doing quite a bit of industrial controls then. In industrial controls, the branch of engineering that is closest related to it in India is called instrumentation engineering, right? But that doesn't mean that only the instrumentation engineers can get into that field. I had never done any instrumentation. I was an electrical engineering graduate in masters and electronics and telecommunication in bachelor's. but the basics stay the same. I was able to pick up the gaps that I had compared to someone who might have done instrumentation engineering. And then once you do controls and you want to do robotics was more like programming. The programming language was very close to Pascal. So if anyone knew either C or Pascal or any other language, they would have figured out the programming of the robot. But the programming also involved understanding of some mechanics, because you have to kind of figure out the motion and acceleration. So you should be also good at some level of physics and mechanics. So that's the traditional industrial robot. Then we are also talking about nowadays robots which, you know, companies from around the world are working on, and there is investments of tens of billions of dollars put into them. Such as the Chinese have this Unitary Robotics is a company which works on humanoid robots. Boston Dynamics has been doing it for decades in the US. Then the company was acquired by the Chinese, and now it's, I think, part of Hyundai. So they have a robot called Atlas, which looks like a humanoid robot. And there are other companies in the US, you know, two of them I kind of remember are the Tesla Optimus robot, which the Tesla is working on. And there's another one called Figure Robotics, which is also kind of similar to Tesla robot. And there are some more. So what's the gold rush here? Why is everybody wanting to put money into this field? What is this new type of robotics? Just like I explained earlier, for traditional robots, you have to explicitly explain every single step, and it can only be useful when it's a repetitive task to be done all the time. But if I want a more general purpose robot where everything is not exactly precise every time, then that kind of robotics is not going to work, right? If I want a robot to do my household chores, say go into the kitchen, take stuff out of the dishwasher, put it in the cabinet, take something out of the refrigerator, put it in the pan, you know, saute it and so forth. It's going to be quite impossible to write that kind of a code, because the stuff that is in the refrigerator may not always be at the same location. The shape of the packaging may not always be the same, right? The the pan that you're going to use may be of different varieties that you're going to have available, because the one you normally use might be in the sink for washing. So now you need flexibility. When it comes to that flexibility, like the humans still are able to work, even though there may not be similar predictability every time, we figure it out, right? So just like AI has been able to do human type of work, like writing an essay, writing an email, now AI should also be able to do these kind of tasks, um, if the AI is added on to the robot. Considering there's a possibility of AI type of intelligence to be added to the robot, so obviously technologists are thinking about what kind of form can it take so that it can do many tasks. The most logical form they can think of, okay, let's make it like a human, because our homes are built for humans, right? Our factories are built for humans. All the things that wherever the robot could take up, say, taking care of the elderly, the hospitals are built for humans, the bathrooms in the hospital are built for humans, right? Operating rooms are built for humans. If we can build something that is like a human, then it will be easier for it to take the job of what the human does. So that's why this mad rush for humans, where they are making robots that can walk, that have arms, that have dexterous fingers. They have a torso, a neck, and everything, so that they can, in the future, do the tasks that the humans are able to do. Right? So that's kind of where the robotics is. But I feel that once the humanoid robots are built, and they have figured out the challenges, such as dexterity of fingers is a big challenge, being able to grab things at a right pressure, not too hard, not too lightly. If you don't hold it firm enough, then it might fall from your hands. If you hold it too firm, then you might break something in your hands, right? So once they figure that things out, also doing fine work, like, picking small things, uh, and then also the AI part of being able to understand how things need to be done. Once that all is figured out, then you may not always need a full robot. You may not need a full robot. Say, for example, if there's a robot that is needed for folding clothes in a retail shop where you're selling clothes, because when people go to the stores, they pick up something to try and then they don't fold it back, and even if they fold it, it's not going to be nicely folded where you can feel like it is presentable to the next customer. So they have usually staff who folds it nicely and puts it back in the rack. So now that folding takes up quite a bit of time, and they could have a table where they just throw all the unfolded clothing there, and there could be a robot that's going to fold every single one of them and pile it up nicely, and then somebody could take and put it on the rack. So if its job is always to just fold, folding also there is need some level of understanding and flexibility required, because every single item could be different. So there could be pants, there could be shirts, there could be shirts of different sizes, there could be shirts of different textures. So it still needs that flexibility where AI is going to help, but still it's always doing the folding. Then you may not need legs. Why do you need legs for something that's folding on a table all the time? So you might be able to cut down the cost and only have the arms and the vision. So there will come other robots from time to time in the future, which may not be a full-fledged humanoid robot, but they would have come from the research and R&D that's been happening with humanoid robots now to make them simple and make them more cost effective.
So, how you mentioned that these robots will be working in households. So, how would exactly these robots learn our surroundings and how to differentiate between a cup or a shirt?
Yeah. So there are many different techniques being used for robots to learn. First of all is to understand their world around them, right? So if we take a robot car, say a Tesla car, the model of the Tesla car already understands what the road is, what the trees on the sides of the road are, what are the trash cans. Sometimes people keep on the road. It can understand that. It can understand pedestrians on the road. It can also understand other vehicles on the road. It can also understand there's a debris on the road it has to avoid. It can also understand there's a bicyclist. It has to avoid that person by maybe even go into the next lane a little bit and prevent from getting close to the bicycle. Similarly, a model, just like the similar to a Tesla AI model, which understands the world, can be trained a little more to understand stuff inside the house also. Just like identifying objects that are on the road, it can identify objects that are inside the house also, such as living room, or say, dining table, refrigerator, dishwasher, sink, this, so on and so forth. So now it has understood the world around it. Now it has to also learn actions to perform in that world. So it, the actions can be learned by seeing what other people do, which is called imitation learning, or it can be learned by trying things and figuring out if it was successful in doing that. Let's say if it knows that it has an objective of taking the jug out of the refrigerator. So it can take the jug out of the refrigerator and put it on a countertop, and it knows that at the end it should see that the jug is on the countertop and it's upright and it hasn't fallen down and it's not broken. So if it takes the jug out and puts it on the countertop and it sees or did it correctly, that will mark it as an appreciation, kind of like an appreciation for its algorithm. Say, hey, you did it right. If it takes the jug out and the jug tips over, then it will mark it as, hey, you did not do it right. It itself, in a cycle, it will do inference, do it, and then say, oh, I did it wrong. It'll do again, do it, and it'll say, I did it right. Just by repeatedly doing it many, many times, it will reinforce that good behavior will get reinforced. Similar to when the child gets up and he or she tries to walk. How do they walk? They see other people walking, and they all of a sudden one day start getting up and they start walking, and then they will take a few steps, bam, they fall down, right? Then they realize that I made a mistake and I didn't put my foot down properly, and then they try it again, they fall down again, then they keep correcting themselves. So that's reinforcement learning. So another way they are realizing that the robots can learn is called imitation learning, right? It's a evolving field, and they're seeing the very, very good results in imitation learning. So how do we learn? We also learn if we have a coach next to us. We look at the coach, how they're doing it, and then we try to imitate them. So the other day I was teaching my son how to pick something, that if you spill something on a table, or if you're cleaning the table, after you have eaten dinner, and if you don't teach a kid the proper way to wipe a table, they just make a mess. They just spread the whole mess, right? If you give anybody who has never cleaned in their whole life, they will take a piece of paper and they just spread it, right? They don't realize that they just to bring it down to one place and just you know pick it up. So I was teaching how to do it, and he figured saw me do it a couple of times, and then he did it nicely. If I had let him figure it out by reinforcement learning, imagine how many times he would have created the mess, and how long would it have taken him to figure out there's a better way to do it. So there are times when imitation learning speeds up quite a bit, because you learn to do it and then you can do reinforcement learning after that, because once you have figured out the basic technique, right? So to give them that basic technique, the robot can observe you, but I don't think the robots are there yet where they can just look at you and figure it out. There will become a point that the robots can not only look at you and figure it out, they could also look at the YouTube videos and figure it out, just like humans do it right now. If I have to make a dish, I can just watch some celebrity chef making that dish, and then I'll figure out how to do it, right? But the robots are not there yet. Think of a robot as a little toddler or a 2 or 3 year old. What do we do with a 3 year old when they have to write? What do we do? I mean, how do we teach them how to write? We not only show them how I am writing, we also hold their hand. That's why I call hand holding. They will pick the pencil, and on top of their hand we'll put our hand, and we'll also write with them, right? We'll be actually moving their arms as they're writing. So similar type of hand holding the robots are also needing right now. So how is that being done? This is something called motion capture kind of suit. Motion capture, somebody else like a human is wearing a motion capture suit which is connected to the robot. And if the robot has to open a door, it's not robot opening the door by itself. It is the person opening the door by utilizing a motion capture suit to open the door. So they will do this action, the robot will do the same action, right? So if you might have seen a Tesla demo in which they were having Tesla Optimus robots. They were role playing. They were acting as bartenders. When people went to that Tesla event, people thought actually the robots were serving them. They would, take beer and give it to them, and they would have small talk with the person who they are offering the beer to. And many people thought it was the robot doing it, but it was actually somebody with a mocap suit in the office looking at someone who is a guest, and then doing that small talk with the guest, which is actually the person who's operating the robot doing it. And also this action of uh, taking the cup and filling it up with beer and giving it to the guest. It was all being remotely controlled. That remote control action was not only serving as a way to temporarily offer a demo of the product, it was also offering a way of imitation learning for the robot. So that was robot was also learning at the same time. So that is imitation learning.
Is it really applicable in real life scenarios? Like if I go and buy a Tesla Optimus, will it actually do the household tasks like how
Yeah,
it's
that is
supposed
the
to
idea.
without the
Mhm.
imitation, like without some. Okay,
So
okay,
they
interesting.
want it to get to the
Um,
point where it learns the basic stuff, such as being able to take stuff out of the refrigerator, using some, you know, pan to put stuff in the pan, putting oil in the pan, turning on the gas stove. So those things are they're teaching, but then it will still need to know some recipe of, say, Maharashtrian cooking. So it was not going to know Maharashtrian cooking, right? So if somebody, a friend of mine wants to learn Maharashtrian cooking, what does he or she do? They will look up Maharashtrian, YouTube channels. So they may ask me, "Hey, do you know any Maharashtrian YouTube channel?" I'll say, "Hey, I suggest this." So Tesla Optimus um, expectation is that right now you're going to teach it to do the basic stuff using imitation learning, but the imitation learning will come to a point at some point in the future where it can learn from YouTube videos, similar to how human learns from YouTube. And then once it has gotten to that point where it can learn from YouTube videos and it can do your household chores, then for kitchen you may not be you may not want to have one unified robot for everything. You say, "Oh, I don't care about any other robot, I want only a robot for my kitchen." Then the household robot for the kitchen may not need to be a robot on metallic legs that it's walking around. It can be on three wheels, like this robotic vacuum, which is a very simple thing. It can be on three wheels like that, because the kitchen, your floor in your kitchen is not, it does not usually have steps to go up and down. It's a flat surface, and it can just go around on those three wheels. And whenever it has to pick something up, it doesn't even need a torso. It can have a telescopic um, midsection, which goes up and down depending on how high it needs to be. If it needs to reach for something high, a higher cabinet, it will just it extend its telescopic midsection and open it. And if it needs to go low, maybe get closer to where to do the dishes or cook something in on the gas stove, then it might come down. So there will be optimized robots for particular use cases, but they will come based on the technology that we are currently getting by utilizing humanoid robots.
Now, can I ask the other question that I asked before, like the India specific skills that are used for robotics, not
Yeah, I
humanoid
think
robotics. So,
how profound are robotics going to be? You can ask this question first. How, when you say that it can do household work, that means if it can do household work, would it also extend to all types of other physical work the humans do? Because these technology thought leaders are telling us if it's anything to do physical, those jobs are going to stay. Right? Isn't that what they tell us? They tell us if it's something physical, those jobs are going to stay. If it's done on the computer, those jobs are not going to stay. They're lying. They're lying. They're lying to through their teeth. So you can ask that question, and then I will explain that it's not. It's just a matter of time. Some jobs are going to go away sooner. Some are going to go away later. But eventually, anything that the human does, even if it's physical, will be done by a robot. Right? It also depends on how often it is being done. Maybe it's done so rarely, then training the robot for that kind of a task may not be practical because it's so rarely being done. But if it's done very regularly, then it is going to be something that's going to be automated. You
so
ask
the
the question
question
and
is,
I'll answer.
how profound is robotics?
Will they? Yeah.
Okay,
Impact on jobs will be, if you
how
can say,
profound?
if you say that it's going to do household tasks, will that mean that the job of chefs could also go away, household help could also go away? And then I'll extend it to say yes.
So is that India specific though? Sorry to derail the conversation, but I'm just curious. Is that India specific, like maybe in the next 10 years?
Yeah, maybe 10 years in the US,
I mean,
15 years in India. I don't know. So there will be, I don't know, timelines are very quite a bit. It all depends on when it will become a commodity, when it become cheap enough for Indians to afford it, right? And India also, it also depend, affordability depends a lot on what is the alternative, right? The labor cost in the US is very expensive. So robots will become reasonable to use in the US lot earlier than they will become reasonable to use in India. Because anybody who is looking to get a robot like that, they're going to compare how much is the robot going to cost me, how much is this household help person who's coming to my house to do the cleaning, how much does he or she cost me, right? When they do the cost benefit analysis, they may continue to utilize the person that has been coming to their house for years, because they feel like, oh, it's not saving me a lot of money and it's at least giving a job to some. But when it comes to the point where the robot turns out to be 20-30% or more cheaper than what they would have cost a person who comes to their house, then they may go with a robot.
Um, yeah. So how profound is robotics going to be in India, and what impact will it have on jobs, entry level jobs in, say, manufacturing or startups or healthcare?
I think what happens in India, I think the slightly a part which is slightly different from other places, which adds a little bit of a challenge for the robots, is that robots kind of need certain standards, right? Where the environment is predictable, and to a large extent in India, the environment is very different from one place to another, so one household to another, or even in the outdoors, the levels of footpaths, the way they are made, a lot of stuff is not consistent. For which I don't know to what extent the robots will be able to immediately adapt. I think the culture of building for suiting robots also will start coming as these get better and better, when you can see that, okay, if only we built this in a way and this robot will also be able to perform some tasks on it, so that also will come along with it, and the infrastructure will also get a little bit more suitable to it. The big change, I think, has come in the way in which the interactions between with the robots are able to happen nowadays, right? In the past, robots, there were the mechanical parts used to be challenging, where there was mostly flimsy. You can prove it, but you can't really put it to any real use. It can't carry any weight. So that has progressed drastically. What it can sense from the environment has also progressed drastically. How it's able to take in that information, and then how the form factor in which you can even add a battery to it in a small form factor, and it's able to become that capable robot which can actually perform. That's sort of all coming together at this point. And then the intensity with which the research is going on right now across different continents is likely to make it happen sooner rather than later.
So, for students that are listening to this podcast, how early should they start thinking about robotics as a career option at school in first year of college, or later once they understand their interests better?
Yeah, for any kind of technical role, and especially with whatever is computer science related, there is going to be a lot of use of generative AI and agentic agents doing quite a bit of work. Um, Whether it is writing the code for robots, or whether it is completing the design of the robot, or completing the printing of the robot, over time, more and more automation is going to come. When more and more automation is going to come, entry level roles in these technical fields are going to reduce, because the entry level work is going to be done by the AI agent. And with one person, there will be a swarm of AI agents that are going to support that person. If you're going to have a person which is coordinating these AI agents to create value, then you obviously will pick someone who is quite proficient, not an entry skilled person, not a mediocre skilled person, but an exceptional person. Because when you have an exceptional, you know, super employee, right, superstar employee, then all the agents are going to function a lot better than someone who may have been an average employee. With the number of employees that are going to be needed being very less, the companies can easily find these superstars. So the likelihood of these superstars to be hired is going to be very high compared to the ones who are not superstars. So if you are going to need to be a superstar, then you obviously need to be better than majority of the people. And if everybody is learning computer science or robotics or what have you in college, and there are some individuals who have learned it many years before college, they already have a huge head start. The likelihood of them being the superstars is way higher than someone who started way later, right? So even though you may be able to learn, you quite likely are going to be able to learn robotics, AI, computer science in college. But considering the world that we're getting in, where exceptional expertise is the one that's going to be in demand, you are going to have a lot more likelihood to get to that level of expertise if you start very early. So the earlier one starts, the better their odds of success.
Yeah, it seems like this is also similar to how we've seen certain prodigies in music as well, students who start off very young. And I see that they have an advantage where college students may already be carrying a lot of college work baggage and stuff like that. If someone has an interest in a certain field, they are able to pursue it with a lot more rigor in the earlier stages. It's just a problem of being able to identify what is that interest of yours. But if you're able to find it, and then you're able to put in that time, then it'll make you a superstar by the time you're getting to college, and you can work on much larger things.
Yeah, Sachin brought up a very good point. Computer technology or technology in general is going to resemble more and more to arts like music, right? Or sports. Just like if you think of any successful sports person, take any successful sports person, you will be hard pressed to find sports people who would have taken the sport when they were already adults. You will even be hard pressed to find people who would be at that level, who would have taken up sport in as teenagers. Majority of the ones who are at that national level or at that superstar level would have taken up sport when they were very young, 9, 10 years of age. So just like how the sports superstars cannot come up unless they start early, similarly music superstars are the ones who would have started, like, classical music very early in their life. Like Arijit Singh would not have been Arijit Singh if he started it in late teenage or in college. He would not be Arijit Singh, right? Shreya Ghoshal would not be Shreya Ghoshal if she had started very late. Just like those superstars had to start very young, similarly, the technology is going to go through the similar phase. The earlier you start, the higher your odds of success. I mean, as we mentioned earlier, it is going to be a world where extreme expertise is the one that's going to be in demand. Whenever there is a scarcity of roles in any industry or any company or any area of work, the number of people that will be hired in that industry doesn't never become zero. It just becomes that the number decreases, and when the number decreases, then there is higher supply and lesser demand. Then you can afford to cherry pick the ones which are absolutely the best. So we are in this time when it is extremely important to be exceptional. And if you want to be exceptional, it is very important to identify what is that area in which you would want to get into depth and know it far better than an average person. So if somebody is wanting to learn chemistry learning at a level where majority of the students, even in the chemistry department, used to learn may not suffice anymore. You may have to go down to the molecular or even you know atomic or even electron level to fully understand what is happening in every single reaction. So you got to go down to the absolute basics. When it comes to electronics, you have to go down all the way to the basics, right, to understand absolutely what is happening in the chip. How are the electrons flowing in the chip? And similarly, in computer science, you may have to go all the way down to compiler, design a compiler, build a compiler, go down to the bit level. You have to find for yourself what is that area in which you will be passionate about going in depth to understand it at the fundamental level. That fundamental level is not going to come from our standard college curriculum. That fundamental level is going to come from you figuring things out on your own with the abundance of knowledge that's available in the world right now. But that's going to happen only when you have the drive and the curiosity for it. So it's important for everybody to figure out what is their area of passion, what they will be passionate about. If anybody is passionate about anything, whether it's technical, non technical, and they can be exceptional at it, they are going to do exceptionally well. But if they are just going through the motion that everybody goes through, everybody goes to college, I'm just going to do the courses, I'm going to just study whatever is taught in class, I'm going to give an exam, there the opportunities for such people are going to be a lot less.
I was actually I wanted to get your perspective on how the college curriculum should maybe, or the college course could be chosen to aid what they may have been doing. So students typically may get introduction to most things and they may explore, but it may not be possible for them to know what they are fully passionate about at that stage. Little bit of, knowing what are the possibilities and then picking that college curriculum may get them to that position. How would you suggest someone should evaluate that?
I think you already answered it. You're giving them that breadth of exposure if they haven't figured out what they want to do yet. I think this is where the American system works out a little better. When you go to college, even though you may have chosen a major when you applied to college, but the initial years of your college, there's not much focus on your area of the department that you would have chosen. They do a lot of general education courses towards the beginning. Someone who may have applied for, say, an engineering field, he may end up finding passion for geography or something else, right? Physics or even history, because there will be enough general education courses that the student can do towards the early years of their college degree, and that counts towards their degree. So it allows people to figure out at an age where they are old enough to figure out what is right for them. And unfortunately, in India, we ask students to pick a stream when they are 10th graders, which is what, 15, 16 years of age. It's not enough time for them to even to understand the world. Their understanding of the world is based on what their elder cousins or relatives or their parents have told them, and is heavily biased by what their parents' aspirations or interests or their opinions are. And when it's heavily biased by somebody else's opinion and somebody else's interest, it's very hard to find passion. So, but we still are in a world that you can still change later on. People may have gone for engineering, and 1 year down the line, they may realize that they have a passion for something else. Like, there are so many examples that people have done, completed the degree also, and they realize they have passion for something else, and then with self study, they became exceptionally or world's best in it. So in this world, we have to be open minded and be willing to pivot. Just new generative AI and vibe coding and what have you, these new things came about. Nobody had studied that. You will realize that some people have become exceptionally good at it. Who are the ones who became good at it? They didn't go to a university to go to learn it. They figured, oh, this is something new, and this is something that looks interesting, this is something that looks exciting to them. They just figured out, research with whatever information was available on the internet, whatever information was available through online portals, online education websites, and try to get as much knowledge as possible, distill that information to figure out what's most relevant to them, and build a unique expertise. Some of them have even converted that into courses for other people, right? So the future is going to not belong to those people who are going to be willing to understand the trends, and based on the trends, quickly identify among those trends what is ringing with them the most and what is exciting them the most, and then self learn and figure out a way to understand it well and become one of the most knowledgeable people about that area.
Yeah, I think I'm seeing increasingly there are so many projects that the students themselves are putting out, and then I look at them and I think that okay, if I were in that school, I would have a lot of time and I would be involved in all of these, building all of them. Whereas when you're now in the profession, you don't get as much time to take it out and then build those projects. So like, students do find that interest. There's so much information out there now for them to be able to do it.
And we especially those of us who are still related or engaged in education, and there is not even a single week goes by when we realize that, man, we should have been born today, rather, in today's, we should have been school in today's day and age rather than when we were there. We're so dependent on teachers, and the quality of teachers wasn't good, and that's, you got stuck. If you didn't go to one of the best schools, there's not much you can gain, because you're not going to get the good schools. So in those times, the schools mattered so much. If you didn't score well in their grade 12 and didn't get into one of the good schools which would have good professors, it was very hard to overcome, right? People still did overcome, but it was harder. But in today's day and age, you can, if you have the passion for something, yes, it's immaterial which college you went to. You could just get the absolute best course for the same topic from Udemy, from Coursera, from YouTube videos, which will be far superior to even a best college in India or anywhere would be teaching. Because when you are online, you're competing with tens of thousands, if not hundreds of thousands of videos. Only the best of the best reach to the top. So the best of the best video for a particular topic doesn't necessarily always come from a well-known professor. It can come from a regular person, just that they had one great video that they were able to make. So now the information availability and the best way to understand it is far easier today than it has ever been, and likely going to get easier and easier in the future.
So the next question is, what can students do to what should students actually look for before choosing a course? Let's say if it's in before their college or in during their college, if they're interested in robotics.
Okay, so first of all, whatever field you choose, you have to feel some level of passion for it. As we have mentioned many times in this podcast itself, it's going to be the era where superstars are the ones who are going to be in demand. In order to become a superstar, you have to have exceptional expertise in the area. In order to get to that level of expertise, you have to have extreme passion to get to the depths of understanding that area. If robotics is one of those areas, then there is abundance of information available online, with many courses that are available online. Try to explore them even before you go to college. And if you feel that those are the areas that are exciting to you, then even though you could have learned them yourself, you still need a degree, because that may be an entry to many of the jobs, because people are called employers are still looking for people with bachelor's degrees. then there is quite a bit of it you may already know, and you might be able to easily breeze through the degree because some of the knowledge you may already have, and you already have figured out where to understand that area better. So in robotics, mechanical engineering would be a good way to go, as long as you learn the computer science and electronics part yourself. Or if you want the course itself to cover all areas, then mechatronics is a good way to go, because many of the schools in India are offering mechatronics now. But that doesn't mean that if you can't get into the mechatronics, that you can't be a good robotics specialist. This is an era where you can learn anything on your own, right? It's just that what you learn in school may not be completely aligned with what you are going to want to pursue. That you will have, the delta you'll have to figure out on your own. In my opinion, even if you go to a mechatronics course in college, even though they are going to cover electronics, they're going to cover mechanics, they're going to cover electronics, they're going to cover kinematics or what have you, it's the level at which they're going to be teaching it is still going to be mediocre or above mediocre level at best. In order to get to that superstar level, you will still have to figure out ways to learn it on your own. So, irrespective whether you go to a field which is completely aligned with what you want to do, or you go to a field which is somewhat aligned with what you want to do, end of the day, it is you who will have to learn it well.
Robotics is often described as a very hands-on field, right? You need to connect the gap between theory learning and application learning, where you actually make something. So, do you really think that colleges in India or courses in India, let it be online courses or anything else, do they bridge that gap right now in providing students the essential knowledge that they need to become a robot specialist or a robot technician?
I mean, India has a lot of resources where people can learn anything. It is just that the coaches that are leading the teaching effort many times do not have that vision to teach it well, right? If the coaching is done by a experienced person who has that vision himself or herself, then there is no limit to what people can learn in India. Let's take example of this Swaram AI. It's unrelated to robotics, but just so to kind of, it's similar in terms of what is possible in India. Swaram AI was able to build a complete foundational model, like, frontier model, completely from the ground up. Completely in India with just 50 people. It's not just that they built a great model; they built a model which is far superior to international models for Indian languages, and they build a model. They build a model with a user interface that they present it to the world, which is super elegant, right? Which is great focus on design with at the same time having that Indian look to it. So if 50 people company in a short period of time can do that, can produce high quality international standards work. Similarly, if there are right individuals in colleges to, they can also provide great education similar to what would be happening in the best places in the world, right? So we at college.dev are also creating such a program, which is a program for robotics in India covering the most cutting edge robotics technologies, including AI, ML, computer vision, kinematics, 3D modeling, 3D printing, electronics, the complete suite. Far, far more current in terms of curriculum than even a mechatronics course at college would have. So if somebody wants to do it supplemental to whatever they are learning in college or high school or wherever they are, because we're not putting any age restrictions on it. As long as you're high school and above, you will be able to do it, right? So we have such a course available where they learn all of these step by step, and at the end they are able to work on a complete humanoid robot based on the toddlerbot project, which is a project being run at Stanford at the moment.
All right. What kind of entry level roles do you think will exist in the next 5 years, especially for students in robotics or robotics adjacent fields for freshers?
Yeah, I mean, there will be lots and lots of robots that are going to come in the world. They will have some level of understanding of the world. So people are saying there is this generative AI which has understanding of words and they can do a next word prediction. But they only understand words, and the words are distributed in its neural network, and you can figure out based on that probability distribution what the next likely word is going to be. But our world doesn't rely on just the words. We rely on seeing things around us. We understand the world. We don't understand just the language, we also understand the world. In fact, our language as understanding is based on our understanding of the world, because we translate the world into a language, right? So understanding the world completely using a language itself is likely not going to be possible. So as the models understand the world model, then there will be many different levels of understanding of the world. Some model will understand everything outside, like driving the car. Some model will understand just the bare minimum what the kitchen would have, or it may understand more, but its scope might be limited to what's to be done in the kitchen, right? So depending on the variety of models that are going, the variety of robots that are going to be in the world, it will create lots of opportunities. One, to even identify what is the right robot for what application, especially in a business setting. Just like how we have consultants right now who go into the industry to figure out how we can optimize processes and reduce cost. There will be a role which will go into the industry and figure out what are the areas where automation can happen, right? That is an opportunity for someone who's going into the industry and identifying where the automation can happen. But that could also lead to someone who's working in the industry to looking at the assembly lines or packaging lines, which with automation their role may no longer be needed. But this is an area where they say some jobs will go and some jobs will come, right? Then there will be all of these robots which may need to be maintained, right? So maintenance jobs will be there. They're not high end, um, kind of like the superstar jobs that we talked about. They are relatively lower end, which is maintenance type jobs, such as how we go to the um, repair or service our cars. We go to the garage to service and repair our cars. Some people are saying we will come to the point where the robots will repair robots, but I think that will take time. Before the robots are going to repair robots, they will rely on humans repairing robots for a while, right? So I mean, it's similar to we will come to a point the generative AI models will improve themselves. We are getting to that point, but in robotics, it will take some time before we will get to the point, or it will be even financially feasible to have a specialized robot to repair a robot. Even though it may be technically possible, it may not become financially feasible. In fact, it may not become financially feasible for a longer period in lower um, cost countries like India, because resources costs are lower. So understanding of electronics, mechanics, um, motor control, motors, sensors, kinematics will be helpful even for jobs which may not be superstar related jobs.
Yeah. I think the early stages, probably just like the Gen AI also went through it, we may have humans sort of supervising the robots and helping them learn, right? The early few generations, they may need more human intervention, because I think already we see them being trained using actual human motion and mimicking human motion. I think there may be some aspects of those that will also be entry level for people.
So if you have a task which requires, you know, picking a bowl and taking, say, vegetables in a bowl and putting them in a pan, that's the action of, being picking up the bowl and then using something to take the vegetables out and putting them in the pan. So how do you train the robot for that action? So you could have the robot mimic the action of a human. And how do you have the human train it? By human will wear a suit on their arms, and then robot will mimic that same action. Because of the mocap suit is doing it, the robot does the same thing. They are also making software where mocap, where the camera is going to look at the hands, and camera identifies the motion, like the bone structure and finger structure, and without even wearing a suit, it will be able to figure out what motions are you doing with your hands and arms, and even body and legs, if it's a something training where the whole body movement is supposed to be tracked. So there will be for some time a requirement for people who can train someone else. You can think of it as a trainer or a coach that coaches humans right now. Now trainer will come to you and he'll say, do it like this, do it like that, right? Who's learning? Humans are learning from the coach. But in this case, it's not the humans that are going to learn from the coach, it's going to be the robot model will learn from the coach, But then with that learning, not just that robot is going to be able to do that task, with that robot learning, all the robots that are using the same model will be able to do that task. Because once the model has learned, that same model can be given as a software update to all the robots, right? So eventually there will be lesser and lesser need for these, because you train one, in that training automatically goes to all. So we have to accept the fact that there will be transient type jobs in the interim jobs, but those interim jobs may not increase over time, they may decrease over time. I mean, there are lots and lots of robots in the world, and if you want more people to be employed, it's not possible to have superstars. Superstars are 1%. That means that's not a huge employment, cohort, right? Even if you are able to employ every single superstar, you're not looking at a lot of people. So you need somewhere lower skilled work where lots of people could be employed. If you're looking for an area where lots of lower skilled people can be employed, maybe in the long run, maybe for the short term, it feels like the robot repair and servicing is that area where there could be lots of people who could be employed. So which we talked about, you don't need to be a superstar specialist in who can understand the in-depths of the robot model to, or world model to repair them. It could be someone who understands different types of motors and knows what motor to use, understands the torque of the motor for different things, understands how the sensors work and how to install them, understands how the gears are, understands how lubrication will work in different joints, understands how to maintain and keep them in good shape, right? Or how to change the battery pack, replace the batteries. Just like how we have a skill right now for iPhone repair person, where iPhones go bad, they have a crack in the screen, and we take it to somebody in the mall, and he replaces the screen. Then they replace the battery. Similarly, robots will also need to be repaired and maintained and serviced. Like I said, there is a field that is very, very aligned with what the robotics professional would need, because robotics is a combination of many fields. It's a combination of electronics, mechanics, um, computer science, right? So mechatronics kind of gives you that, but that doesn't mean that mechatronics is the only way to go. Also, there are not many colleges in India that offer mechatronics, but that's not the dead end. You can still learn it by learning it on your own, but you can have a degree somewhere in a related field, and the related fields are also the other ones that you just mentioned, right? So if you're learning about IoT, you will understand the electronics part of robotics already through your degree. Then you will have to fill the gaps on other areas on your own. End of the day, the most specialized person is not going to depend on what college they went to and what curriculum they followed or what branch they had. That was even in our time. The most specialized people will be the ones who will self learn and get into the depth of things. Even if you look at Bay Area right now, in the top tier programmers who will be principal engineers, you will be surprised to find many of their backgrounds, they have a degree in civil engineering. And in civil engineering or mechanical engineering, they would have hardly done one course throughout their 4-year degree in computer science. How did they end up becoming the world's best computer science engineer? Because when they went through a 4-year mechanics degree, they built the ability to problem solve. Because mechanics is not easy. Civil engineering is not easy. You have to do a lot of math, complicated math based on word problems, and figure out what the right solution will be. So they learned a life skill of how to tackle challenging problems. But then when they had to do programming, it was like, oh, it's easy, I can program it. They picked the programming on their own, and they not only picked it, they went all the way to the understanding at the real fundamental level, right? And they became all the way the best engineers in Bay Area. Not that everybody is a mechanics engineer, but there are many who have completely no relation with what they studied, and they ended up becoming one of the best in the world. So
Yeah,
it all
and
depends.
increasingly, I think with other subjects also sort of, crossing over this. You have robotics in medicine with different machines and devices, and you may probably have robotics in construction. You already have 3D printing in construction nowadays. So I think getting some hands-on at an early stage, irrespective of what path you may take later, getting a hands-on with these electronics and really understanding them will help later on for you to find your unique path as
Yeah. You have to have that, first of all, confidence in yourself that you can self learn. If you start believing that everything that you have to learn has to be taught to you by someone, then you already lost the plot. The first thing for anybody is to figure out how do they gain the confidence in themselves that they can learn anything on their own, right? I mean, I have a nephew who just who graduated with a medicine degree from Cambridge. He's a medical student. He's not a computer science guy. He recently did an internship at Stanford in AI for doing some AI related computer science work. But he had a lot of confidence that he can figure it out on his own, because that confidence he has gotten by getting into Cambridge and getting into one of the most competitive programs in the country. It's like you can feel that he thinks that if I could do that, why can't I do this? And he doesn't think that, okay, I have to go to a college first to learn it. I mean, I because of the abundance of information that's available on the internet, you can figure it out. I mean, Suchin and I also were not computer science people. We Once we figured out that this is something that we want to learn, we learned it on our own, right? And same is true with even the best of the best, many best of the best, very successful programmers in the Bay Area. And considering that this was not something they learned in college, and this was something they learned out of their own passion, I feel they must have learned it at a better, you know, in lot more in depth than somebody who may have gone to college, because the college person will learn it based on the curriculum and what's the exam. This guy is not learning for the exam. This guy is learning for knowledge, right? So end of the day, it all depends on what passion you have and whether you will enjoy that process of learning. And that is why it is very important to figure out what will you be good at, right? So I mean, some people say this is unrelated to technology. People say, oh no, even if you have to cut grass, cut it well, because even if you cut grass well, you're going to do well. It's actually true. Even a landscaper in the US makes quite a bit of money if they're good, right? So whatever you do in life, do it really well. Do not do a mediocre job. And figure out that early in your life, or as early as possible, what you will be passionate about. Because if you're passionate about something, then it will not feel like, okay, I need to get out of here as soon as I can, because when will my 8 hours be done? If people have that mentality of, oh, when will my 8 hours be done, then in the new world we are getting into, it's going to get harder and harder. I mean, I studied electronics and telecommunication in India, and I came to US, and um, I came to US to do masters in computer science, but computer science degree was turning out to be very expensive, because I was being asked to do 10 um, prerequisite courses, because my coursework in India was not related to computer science at all. It was electronics related. But I had a feeling that I could learn it on my own. It didn't make sense for me to double the cost of my degree, because I didn't have that money to pay for another degree pretty much. So I decided to switch over to electronics degree in the US. Electrical engineering they call it. I finished my electrical engineering degree, and your life forces you to take different paths sometimes. Sometimes you want to do something, but it's not possible to do what you want to do. And during that time, electronics was going through a very tough phase. Intel was laying off people. It was very difficult to get a job in electronics field. I joined a company which used to design packaging and assembly lines in the California Central Valley, and they had clients like Tropicana and Del Monte and Constellation Wineries. They used to design packaging lines. So I was their project engineer, project manager, designing packaging lines. So I would do complete end-to-end project engineering and programming, project engineering and programming and project management. So I did it for 2 to 3 years, and then I decided to change the industry completely and get into a software industry related to healthcare. So I pivoted completely and joined a company which was a very fast growing company. And when I joined it, they had only 200 and some employees. I joined to be to be part of their core team of 25 people. And then that company grew a lot. It went to 10 thousands of employees, I think 7 or 8,000 by the time I left it. So most of the time, considering it was growing really fast, I did not end up doing technical work. Most of the time there, I was in management because it grew so much that we just kept moving up the chain. So I did quite well. I was well known for leading teams which would be motivated, um, and that's, rest is history. I just was there till I started Young Wonks, and I wanted to do something which makes an impact in the lives of future generations. It was not about money, it was about making an impact. So I derived a lot of joy in teaching kids. And I hadn't touched programming for almost 8-9 years before that, because I was mostly doing senior management work, right? So I picked up a book and revised and tried to figure things out and started teaching. And when I started learning it on my own, I realized that, oh, everybody else just teaches it in a very complicated way. Things can be made a lot simpler than the way they are explained in books. And then we got, I mean, I interviewed a lot of people. Then I was introduced to Suchin by someone because he was also passionate about teaching. I talked to him and I felt like there's a right match of wavelength, and he really was also keen into teaching kids the right way. It was feel like a calling for him too, and since then we have been working together. And Sachin can explain his background. His background is also very interesting. He used to do something completely different, computer science before.
That's true. I think so. For a little bit for an Indian, I think for Indians, there are multiple times where you need to make a choice, and the first one comes around where when you finish your 10th standard and you need to take a call on whether you go biology or computer science, commerce or electronics. Although I had a feeling that I had interest in electronics, but everybody's guidance was keep your options open, do biology, which I did take, which is sort of interesting. It was beneficial. And then I took up, I actually got a very high paid seat for electronics. And then I felt like I shouldn't be paying for something that I, didn't deserve. So I took a lower paid fee seat for telecom, which was pretty much the same course and had pretty much all the same. And in the end, I actually learned a little bit about mobile communication and satellite communication as well, in addition to it. And then it was surprising that the subject that I chose to do my master's in is the subject that I failed during my bachelor's, which was FPGA and VLSI. So I did join after college through placement Tech Mahindra. I had no intentions of studying any further at that point, but because of the kind of way these companies work, I was on the bench for about a year. And I felt that the most energy that I had soon after college was not being used at all. So I then, I took a call on going to the US. I did my applications. I might have been over, zealous in my applications. I was rejected by all colleges I applied to. I then applied again. And fortunately, this time I got accepted to most of the colleges I applied to. I chose San Jose State because it was close to Silicon Valley and close to all the companies. And so I went there for electrical engineering. And I really wanted to make use of that opportunity, because without doing something different, it wouldn't make sense to have gone through this process. So I did put in all my hard work, and for the whole of my life, I was an average student, but I was able to really excel because this was something that I chose to do. So I was able to put in that hard work and handle multiple jobs at the same time, handle a lab as well, and then it got me fortunately a scholarship which waived off half of my fees. So I was able to work and pretty much keep all the expenses down during this whole time. I did work as an intern for Marvell Semiconductors for close to a year almost, where although I realized that I liked technology, but I didn't like being in those dark cubicles the whole day. I needed more interaction. And that's why I think I was looking out for, I was working just, I was stalling. I was working for some unpaid internship, trying to find some meaningful opportunity. And that's where, I met Vishal as well. And his vision sort of interested me a lot. It was something that was ahead of time when I was there. And it was a complete shift again for me from something that I'd done hardware and VLSI to then come to software. And again, in a similar way, started with basic LEDs and basic conditions, and then brought myself up to a point where you can teach as well. The same thing happened to me as well. I had tried multiple times to learn programming by myself in the past, and I had not succeeded because I had not learned it the right way or did not take the right steps. I tried to jump directly to Android, tried to do multiple things to learn programming, but then when along with teaching, we started going at it from a step-by-step way, it made all the difference. And then, since then, it's been close to 12 years and a lot of teaching, a lot of students, a lot of learning.
I mean, once you get that confidence that you can figure out anything, then you will never get stuck in life. You will figure out a way to do it. If you notice, our team has produced so many amazing products which are comparable to companies who have hundreds, sometimes thousands of employees. And when we started working on those products, people said, "Oh, you're hardly a small team, and how will you be able to build such a product, like a complete video conferencing system, a good quality video conferencing? How can you build that? And with functionalities which are beyond what Zoom offers." I mean, once you really believe in yourself, you will be able to do magic. And every one of the products that we have started to do and which we initiated, they were all completed and they are already being used by people. And it's not that they are compromising and accommodating to use it. It provides better experience to them than what the existing market leader products are able to provide. So first, it is important for anyone to have the confidence in themselves that they can learn anything if they want to, and they can figure out anything if they want. There are so many people in the US who don't have any technical degree, but they still were able to learn programming and do really well. I think it was eye-opening for me when I came to US. In order to make sure that I'm not dependent on my tuition money for my living expenses, I made it a point immediately to get a good on-campus job. Right, so I was pretty good at technical skill. I had good, decent technical skills, so I was able to get immediately a job in IT department at the library. And the next year, I was able to get a job in the IT services department at the university obviously as a student assistant. My cubicle, as a student assistant, my cubicle was next to a guy who was an American guy, and he was a programmer, like a full-time programmer for the university. And when I asked his background, he had done a degree in economics. And when I asked him, "How did you learn computer science?" he said, "I just figured it out on my own." Right? And when you look at examples like that and you believe that, "Oh, I have pretty good IQ and I think I can figure it out. I am doing electrical engineering masters, right, which has electromagnetic, subjects like electromagnetic wave theory and complicated probability math and all of that. If I can figure that out, why can't I figure this out?" Right? So if you really start believing in yourself, then anything is possible. You can do anything. If somebody tells you, "Oh, don't do this because you don't have expertise in that area," right, you have not worked in that industry for 10 years, ignore them. If you really believe that you have value to add in any industry, any work, jump into it. If you believe in yourself, you'll be able to figure it out. Right? If you look at most transformative people in any industry, what's that Oyo person's name? Ritesh, I think, right? He just dropped out of college. He had absolutely no background in hospitality industry. He changed the complete industry because he had a vision and he had a belief. Right? If you have that vision and belief, don't let the naysayers impact you. Just go for it, and you will be able to figure it. Especially in today's day and age, everything in the world is available. All the knowledge in the world is possible. Especially now with generative AI and ChatGPT. If you don't know about something, ask ChatGPT to tell you what to do. Right?
Really great hearing your stories. Real life stories are much better than hypothetical ones, I feel. And I think this feels like a good place to stop the podcast. You have answered most of my questions. And for students that are listening to this podcast, robotics, as you already know this by now, but still, robotics is not about having the perfect degree or the perfect course. It's about curiosity, consistency, and learning on your own and building real world skills step by step. Thank you again for listening to this podcast. This is HigherEd Horizon powered by College.dev. We'll see you in the next one.